Hello children, welcome back to chemistry session. In previous session, we have seen methods to express concentration of solutions. In that we discussed about mass percentage method, volume percentage method and mass by volume percentage method. In today's session, we are going to talk about collidal solutions and suspensions. Let us start today's section, children. Suspension. What is meant by suspension? Suspension is nothing but suspension is a heterogeneous mixture of solid in liquid. For example, when we are suffering from cough, then we take cough syrup. The cough syrup is an example of suspension. Because when you see cough syrup, you might have observed that shake well before use. Because cough syrup is an example of suspension. That means suspension is a heterogeneous mixture of solid and liquid. That means the solid solute is not completely dissolved in the liquid solvent. That's why suspension is a heterogeneous mixture of solid in liquid. That's why it is called as heterogeneous mixture. Next, when we talk about properties of suspension, properties of suspension are suspension is a heterogeneous mixture and the particle size of suspension is more than that of particles of the solution, because solution is a homogeneous mixture of solute and solvent and the particles of the solute cannot be seen by naked eye, but the particles of the suspension can be seen by naked eye because the particles of the suspension are greater than that of the solution. That means the particle size is more than 1 nanometer. The particle size is more than 1 nanometer. That's why we can observe the particles in suspension. And these suspensions are unstable solutions. This is because when you disturb the suspension, then solute particles are dissolved. Solute particles are present in the suspension solution, but when you place undisturbed for some time, the solute particle settled at the bottom of the container. That's why suspensions are unstable mixtures. And when a beam of light passing through them, then it can scatter. So suspension scatter a beam of light passing through them when we disturb the suspension, because while disturb the suspension, then the particles are dispersed in the particles are present in the solvent. That's why when we disturb the suspension, then beam of light passing through them, then we can observe the particles in the suspension. We are able to observe the particles in the suspension by naked eye. That means it can scatter a beam of light passing through them. And we can separate the components of the suspension by filtration technique. By filtration technique, we can separate the components of the mixture and we can separate the components of the suspension. Example of suspension are sugar syrup, not sugar syrup children, tonic. Tonic is an example of suspension. Not only tonics, but also sand particles or mud particles are dissolved in the water because they settle at the bottom. When we disturb them, those particles are dispersed in the solvent. But when we are kept away, then those particles are present at the bottom of the container. That's why suspensions are heterogeneous mixture of solid in liquid. Next, let us talk about colloids. Colloids. What is meant by colloids? Colloids looks like homogeneous mixture, but colloids are the heterogeneous mixture of dispersed phase and dispersed medium children. Here we use the word dispersed phase and dispersed medium. What is meant by dispersed phase? Dispersed phase means the phase in which colloidal particles are present is called dispersed phase. Dispersed medium means the medium in which colloidal particles are dispersed. I am repeating, children. Dispersed phase. Dispersed phase means the phase in which colloidal particles are present in small concentration. And dispersed medium means the medium in which colloidal particles are dispersed. It's called dispersed medium. For example, clouds. Clouds is an example of a colloidal solution because clouds is like a homogeneous substance or homogeneous mixture, but actually clouds made up of two components, that is dispersed phase and dispersed medium. Dispersed phase and dispersed medium. Not only this cloud, any of the colloidal solution contain two components, dispersed phase and dispersed medium. I told you dispersed phase means the phase in which colloidal particles are present in smaller concentration or lower concentration. If you see the clouds are appears in black in color and the clouds carry water droplets. That's why dispersed phase in clouds is liquid. Liquid is dispersed phase because which is present in lower concentration, and dispersed medium is in gaseous phase. It's nothing but clouds. That's why clouds is an example of colloidal solution. Not only clouds but also milk. Milk is an example of colloidal solution because milk contains two components, dispersed phase and dispersed medium. Dispersed phase and dispersed medium. The dispersed phase in milk is in liquid state. Dispersed medium is also in liquid state. That's why milk is a liquid type of colloidal solution. We know that milk contains components like carbohydrates, proteins, fats and vitamins. These are called micronutrients. These micronutrients are exist in liquid state and it mostly contains water molecules. That's why milk is an example of liquid kind of colloidal solution. So these are some of the examples of the colloidal solution. Not only clouds and milk but also pumic stone. Pumic stone also example of colloidal solution. Next, colored gemstones. Colored gemstone is also example of colloidal solution. Next, sponge, shaving cream, foam, fog, mist, blood. Human blood is also example of colloidal solution because human blood contains different kind of cells, RBC, WBC, blood plasma and water molecules because human blood is made up of nearly 80% of water, and it also contains blood cells like white blood cells, red blood cells and blood plasma. But it looks like a single component. It looks like a homogeneous mixture, but actually it is made up of two or more components. The components of the colloidal solution is dispersed phase and dispersed medium. Now let us talk about properties of the colloidal solution. Colloidal solutions looks like homogeneous mixture, but actually they are heterogeneous mixture. And when we talk about particle size of colloidal solution, the particle size of colloidal solution are very small than that of suspensions. That's why we cannot observe the particles of the colloidal solutions by naked eye. But the particles of the colloids, they can scatter a beam of light passing through them. This phenomenon is known as Tyndall effect. Tyndall effect means the phenomena of scattering a beam of light through colloidal solution is called as Tyndall effect. How does colloid possess Tyndall effect? Because the particles of colloids cannot be seen by naked eye, but when a beam of light passing through them, then the particles of the colloids can disperse passing through them. They can disperse in the beam of light. Then in that case, we can observe the particles of the collide when a beam of light passing through the colloidal solution. This phenomena is known as Tyndall effect. That's why Tyndall effect means scattering a beam of light through colloidal solution. You can observe Tyndall effect in our room also. Suppose when a narrow beam of light enters to the room, then when dust particles are dispersed in the room, when dust particles are dispersed in the light, narrow beam of light, then we can observe the dust particles are present in the narrow beam of light. This phenomenon is known as Tyndall effect. We can also observe this Tyndall effect in dense forest. So when a beam of light is allowed to pass through the dense forest, then dust particles or mist particles dispersed in the narrow beam of light. Then we can observe particles of mist or dust particles in the beam of light. And we can also observe this Tyndall effect in the cinema theaters, because when the light is emitting from the projector, then we can observe dust particles, fine dust particles are dispersed in the narrow beam of light from the projector. This is also nothing but Tyndall effect. So this phenomenon is known as Tyndall effect. Tyndall effect means scattering a beam of light through colloidal solution. So colloidal solutions also possess Tyndall effect, and the particles of the colloids cannot be visible by naked eye because the particle size is smaller compared to that of suspension. Can we separate components of the colloids? Yes, we can separate the components of the colloid by a technique called as centrifugation technique. Suppose, how do we separate components of blood? We can separate blood components in centrifugation technique. By centrifugation technique, we can separate the components of the blood. Because if we go to any diagnostic lab, then the person will take samples of blood and urine. They'll take the samples of blood and urine in a centrifuge tube, and they put centrifuge tube in the centrifugation. So gentle spinning of centrifugation separates the mixture into two components. The component which has less density, which present at the top layer, and which has high density, which is present at the bottom of the layer. So centrifugation of blood gives out blood plasma and water. Water has low density, so which floats, and the plasma has high density, so which things are present at the bottom of the centrifugation. This is the way we can go for testing of blood samples and urine samples in the diagnostic labs. And this is the way we can separate components of the colloids, because colloids looks like homogeneous mixture, but actually they are the heterogeneous mixture of two or more components. So these are the properties of colloidal solution. Now compare the three solutions: suspension, colloids, and true solution children. Now let us compare these three. Example of suspension: chalk water. Chalk water is an example of suspension. Not only chalk water, but also syrups and tonics. Cup syrups and tonics are example of suspensions. Colloids, I gave you some of the examples like cloud and milk, blood, sponge, rubber, etc. Sponge, rubber, shaving foam, shaving cream, humic stone, colored gemstone, etc. These are some of the examples of colloids. Next example of true solution: sugar solution, salt solution. These are some of the examples of true solution. Not only salt solution, sugar solution, but also copper sulfate solution, barium chloride solution, potassium chloride solution, etc. are examples of the true solution. Now let us compare the true solutions, so suspensions and colloids. First, let us talk about particle size. We cannot observe the solute particles in true solutions because the particle size is very less than 1 nanometer. Particle size is less than 1 nanometer in solution or true solution. Next, suspension. The particle size of suspension is more than 1 nanometer because you can observe the particles in suspension. Coming to colloids, the particle size of colloids exist in between those of true solutions and suspension. We can say that in between the size of true solutions and suspensions. This is called particle size of true solutions, suspensions and colloids. And nature of mixture. True solutions are homogeneous mixture. True solutions are homogeneous mixture. Next, suspension are heterogeneous mixture. Suspensions are heterogeneous mixture. Colloids looks like homogeneous mixture, but it's a heterogeneous mixture. Colloids looks like a homogeneous mixture, but actually colloids are heterogeneous mixture. Next, let us talk about Tyndall effect. Tyndall effect means scattering a beam of light through colloidal solution is called as Tyndall effect. Suspensions do not possess Tyndall effect. Suspensions do not possess Tyndall effect because the particles are completely, the solute particles are completely dissolved in the solvent. That's why they do not possess Tyndall effect. Next, coming to suspensions. Yes, the particles are big enough to see a observed by naked eye. That's why suspensions possess Tyndall effect. The particles are big enough to possess Tyndall effect in suspension. Colloids are the particles are in between those of true solutions and suspension. That's why colloids also possess Tyndall effect. And true solutions are stable in nature because when you disturb the solutions and when you place aside, then the solutions are constant. And suspensions are not stable solutions. These are not stable in nature because when you disturb the solution, when you disturb the suspension, then solute particles are dispersed in the solvent, and when you place aside for some time, then after some time the solute particles are present at the bottom of the container. That's why suspensions are not stable in nature. Coming to colloids, colloids are stable in nature because when you disturb them, then the particles are not enough to observe a naked eye. That's why they also are stable in nature. Next, separation. How can we separate the components of suspension? Components of suspension can be separated by filtration technique. By filtration technique, components of suspension can be separated. How can we separate components of colloids? Components of colloids can be separated by centrifugation technique. Centrifugation technique we can observe in diagnostic lab children. So centrifugation technique, by centrifugation technique we can separate components of the colloids. What about true solution? Components of true solutions cannot be separated by filtration. By evaporation. By evaporation or crystallization. By evaporation or crystallization techniques, we can separate components of the true solution. This is today's section, children. In today's section, we discussed about suspensions and colloids. We also discussed about comparing true solutions, suspensions and colloids. This is today's section. I hope you understand today's section, children. We'll meet you in next session. Thank you.